We'll break it apart after you have it written down. So using inverse matrices to solve systems of linear equations. So if if we designate the first matrix, matrix A. If matrix A is some n by m matrix, and it has an inverse, so it has an inverse of A to the negative 1 power. Remember, that's just our notation for inverse. So if you ever see that negative 1 exponent, that's just this notation saying that's the inverse. So if the inverse exists, then you can actually solve the system and come up with a solution. For those problems where you got the inverse does not exist, then that's one of those scenarios where you would have either no solution or you would have infinitely many solutions. And we write our answer in set notation. All right, so if A is some n by n matrix with an inverse, and we designate matrix X as some n by 1 matrix of some variables, and B is another n by 1 matrix, then we have the following matrix equation. So A matrix times X matrix. We know how to do matrix multiplication, right? Yes, we hopefully remember how to do that. Row by column. You take the row, swivel it over to the column. Right? So A times X matrix is equal to B. If I had to solve that for X, okay, if it was just A times X, the inverse of multiplication is division. Well, we're not doing A times X, we're doing A matrix times X matrix. So to do the inverse of that, you have to find the inverse of your matrix A and multiply it by matrix B. And I want you to take notice to this notation. So to find our solution matrix, we're going to take the inverse of matrix A, which you guys should be experts on, because you did it for homework, and you're going to multiply it by matrix B. So now we're just taking two skills that we know how to do and bringing them together. Okay? So again, I think it's best seen in practice. So we're just going to jump right to a system. Hopefully that works out pretty nicely. So here's our first system. We've got 2x minus 3y equals 1. And x plus 5y equals 20. Now you are going to be asked on your test, it's going to say, use this method. So you need to make sure you can use all the different methods. So here it's saying, use the inverse of the coefficient matrix to solve each system. Now think back to when we did augmented matrices, Ian. My coefficient matrix is made up of the coefficients of the variables, right? So my coefficient matrix, I'm going to call it A, is the matrix of 2, negative 3, 1, and 5. Now if we were doing row operations, which is a different method, I would make this a bar, and I would put 1 and then 20, and I would do my row operations to get 1, 0, 0, 1, and then whatever was left over on the other side would be my solutions, right? Like what we did over there. But now we're asked to use the inverse of the coefficient matrices. So I'm going to have to find A to the negative 1. That's what we don't know. I have to find the inverse of A. And my B matrix is going to be a 2 by 1 matrix of 1 and 20. And that's not going to come into play until I find my inverse of matrix A. Once I find that, then I'm going to multiply that by that, and that will result in my solutions. Okay? So let's practice finding the inverse of a 2 by 2. So we've got 2, negative 3, 1, 5, bar, 1, 0, 0, 1. What would you guys do first? Switch them or deal with the fraction? Flip them? Paul wants to flip? All right, so let's flip R1 and R2. So 1, 5, 0, 1, 2, negative 3, 0, or 1, 0, sorry. All right, what's my first move? I like that idea. Negative 2R1 plus R2. So row 1's not changing. 1, 5, 0, 1. Am I writing too small? Can you guys see that? Okay. You can't see it? So what are my elements going to be of row 2? First one's going to be a 0. Then what are we going to get? Negative 13. What's my next one going to be? 1 and negative 2. Good. Is everybody okay with that step? All right. My next goal is to turn that negative 13 into a 1 by multiplying by negative 1 over 13. So I'm going to do a negative 1/13 R2. So 1, 5, 0, 1. That just keeps hanging out. 0, 1, negative 1/13 and 2/13. Okay, so row 2's done. What's the last step I have to do? Turn the 5 into a 0 by doing what? Good. Negative 5 R2, add it to R1. So row 2 is not going to change. 0, 1, negative 1 over 13, 2 over 13. So then I get a 1. I've got a 0. I'm going to use my times negative, oops, got to turn my calculator on. Negative 5 times negative 1 over 13. I don't know why I'm doing that, because I'm just adding 0. That was silly of me. So what is it, 5/13? And then the next one would be negative 10/13 plus 1, math frac, which is 3/13. Okay, so we found the inverse. If you trust that you did it well, then continue on, or you can use your calculator to check that to see that you did do it right. I'm going to trust that we're okay. So there's my inverse. Now I'm going to take my inverse and I'm going to multiply it by my b, which is 1 and 20. So this is a 2 by 2. This is a 2 by 1. So my resulting dimensions will be a 2 by 1. So 2 rows, 1 column. So do we remember how to multiply? Take my digits in the first row, connect them with the digits in the column. So the 5/13 matches up with the 1. And I'm going to add to that 3/13 times 20. So that would be 5/13 plus 60/13. So 65/13. So 65 divided by 13 is, oh, look at that. It's a 5. That's nice. Do the same thing with the second row. So negative 1/13 times 1 plus 2/13 times 20. So 40/13 minus 1/13 is 39/13, which is 3. So my solution is 5, 3. Okay, so you can use your calculator to do that easily for you. Let's go ahead and submit in matrix A in your calculator. Go ahead and practice it. It's good to practice it. So matrix A, input your matrix A, go over and edit it. It's 2 by 2 of 2, negative 3, 1 and 5. So now we are creating a B matrix. So go over and edit your B, which is a 2 by 1 of 1 and then 20. And hit second mode to quit out of that and clear my screen. So once you have your A and your B in there, if I hit second matrix A and then hit my inverse button, which is up there highlighted in red right now, and then multiply it by matrix B, I get 5, 3. Okay. So while you have your calculators in hand, I'm going to give you a really crazy one. But I was going to give you guys some homework and then realized it was a 4 by 4 and thought, wow, that would not be fun. So if you had to do problem 33 in your textbook, which is x plus y plus 2w equals 3, 2x minus y plus z minus w equals 3, 3x plus 3y plus 2z minus 2w equals 5, and x plus 2y plus z equals 3. How could you do it on your calculator? What would you guys do?
Is there only 3 variables for the...
Yep, so you would have a 0 for your z.
Okay.
So go into your matrix A, go over to edit. We're changing it to a 4 by 4. Well, so if there's no z, put a 0 there. So it would be a 1, 1, 0, 2 for your first row. What would it be for your second row?
2, -1,
Yep.
1, -1.
Good.
3,
3, 3, 2, -2. 3, 3, 2, -2. And then your fourth row would be 1, 2, 1, 0. 1, 0. And then you would go into your matrix B and turn that into not a 2 by 1, but a 4 by 1. Make this bigger. Which would be 3, 3, 5, 3. And then second quit out of there. And so then I would select A, the negative inverse times B. Look, there it does it. So there's your answer. Okay? So that would be insane to do by hand, right?
Can you even do it by hand? I feel like that would cause a lot of pain.
Yeah, so it'd be 1, 0, 0, 0, 0, 0, 0, 0, 1, 0.
I think that would actually take up like
That'd just be a bunch of pages. All right. So what we are going to do now, that was the last of our notes, is you want to get started on your homework problems? We can do a few together. Why don't we do that? So get whatever paper you're going to complete your homework on. We'll start the first few together and then set you free with the rest. All right, so page 215, 216, doing numbers 23 through 26 and 29. So number 23 is negative x plus y equals 1. Now again, if I was out there in the real world, probably just use elimination, because you always eliminate right away, right? Just solve it. We need to practice all the methods, because that's what makes us smart. Being able to problem solve different things. Okay, so what's my A matrix? Gonna be -1, 1, 2, -1. I'm gonna go right away to the inverse. 1, 0, 0, 1. That's going to give me my inverse. Alright, what would you guys do?
Gonna make it into a 0.
2R1, add it to R2. Go ahead and pull that move. Huh?
You get -2?
Why would you want it to be negative?
Because we're like making it a 0 or something like that.
Yeah, but it already is negative.
It's like
Multiply
a 2
by
to
a
me.
Did I say -2 or are you saying -2? Now you're confusing me.
Who knows at this point?
You're multiplying by a positive 2. Is that what you guys got? 0, 1, 2, 1? Yeah? Paul, you getting that?
Yes, I am.
You ain't getting that?
Yeah.
Why is your phone on your desk? Interesting turn of events. Row 2 is done. It's our last move. Well, not last move, we got 2 moves. The last one's our new part. Turn this one into a 0 by doing a -1 R2, add it to R1. So row 2 doesn't change. That stays a -1, that goes to a 0. -2 and 1 makes -1. -1 and 0 makes -1. It's our last move. Yeah, just do a -R1. So 1, 0, 1, 1, 0, 1, 2, 1. So my inverse is 1, 1, 2, 1. And we're going to multiply that by one, 1, right? Those are your numbers on the other side. Okay, so multiplication. It's going to result in a 2 by 1. This one matches up, this is very confusing because we got a whole bunch of 1s. This one will match up with that one, so 1 times 1, plus that one will match up with that one, so another 1 times 1. So my x is equal to 2. Now do it to the second row. 2 matches up with the top one, 1 matches up with the bottom one. So that gets me 3. So my solution is the ordered pair 2, 3. That wasn't too terrible. Right. All right. 24. Oh, this one's even better. 24 is x plus y equals 5, x minus y equals -1. Why is that one nice? All my coefficients are 1s. So we've got 1, 1, 1, -1, 1, 0, 0, 1. What are we going to do?
-1R1.
Yep. Add it to R2. So 1, 1, 1, 0, 0. That goes to what? -2? -1, 1. Next move. Good. 1, -1/2. R2, I like that idea. 1, 1, 1, 0, 0, 1, 1/2, -1/2. Last move. Good. -R2, add it to R1. So 0, 1, 1/2, -1/2. That's going to be a 1. That's going to be a 0. So -1/2 plus 1 is +1/2. And that's going to be another 1/2. That's my inverse. Pretty much all 1/2s. I'm going to multiply it by 5, -1. So what's my first line going to do? 1/2 times 5. Add it to 1/2 times -1. So 5/2 minus 1/2 leaves us with 4/2, which is 2. And then here we're going to do 1/2 times 5 plus -1/2 times -1. So 5/2 plus 1/2 is 6/2, which is 3. There it is. It should just all be 2 3s. I don't know. 25. Oh, nope. There is a -2 as your x, though. All right, so you've got 25 and 26 to do on your own. I'll throw number 25 up there if you want to continue doing it for the last few minutes. You still have 6 minutes, which I'm sure you can get one done. I can put the rest up too, so you guys don't have to take books home if you want. 25 is 2x minus y equals -8. 3x plus y equals -2. 26 equals 12. 2x minus y equals 11. And I did throw a 3 by 3 at you. So 29 is your 3 by 3 matrix. There you go. 3 problems that you need to complete on your own.